This is lesson 9.3, page 569, Find Special Products of Polynomials. Couple things before I get rolling in this video. Think about some of these terms. Products means multiplication. You know what polynomials are. They are monomials or multiple monomials being added or subtracted together. The word special here means that there are a couple cases where there are shortcuts to actually double distributing, triple distributing, like I taught you in lesson 9.2. So there are certain problems that instead of having to do that in just a few seconds, we can do a shortcut in special cases. We're going to talk about those special cases today. The diagram at the right shows a square with a side length of a plus b units. So you notice the top is a plus b and the bottom is a plus b units. You can see that the area of the square is a squared plus 2ab plus b squared. Let's take a look at that. A times a is a squared, a times b is ab. Here, b times the a is ab and b times b is b squared. So you can see here's my a squared. Here are my two ab's. Let me circle them. There's my two ab's, and there's my b squared. This is one version of a pattern called the square of a binomial. Okay? To find another version of this pattern, replace b with its opposite. Well, if I make this negative, the only change it's going to make is these two will end up being negative. So I would end up with a squared, which you see. I have negative 2ab, and I have b squared. These two cases show me how I can find the square of a binomial without having to double distribute. It's a simple shortcut. Okay? Look at these. I can take the first term, a, and square it. I can take the last term and square it. And then if I take a times b and double it in the middle, there's my answer. All right? Let's look at these samples here. All right? X plus 5 squared. Here's the shortcut. Take x and square it. Take 5 and square it. That's 25. And in the middle, take x times 5 and double that. There's your 10x. Now I want you to notice, if I actually double distributed, I'll get the same answer. It's just double distributing takes longer. X times x is x squared. X times 5 is 5x. 5 times x is 5x. 5 times 5 is 25. Can you see how I'm getting x squared plus 10x plus 25? But if I see that I'm squaring a binomial, I can just use the shortcut. Square the first term, square the last term, and then multiply those two and double in the middle, and you have it. If it's a minus for the binomial, it's the same pattern, you just have a minus in the middle. So take the first term, 2x, and square it, that's 4x squared. Take the last term, negative 3 squared is positive 9, and then take 2x times negative 3 and double that, and you get negative 12x in the middle. So it's just a shortcut. Let's use that to solve these. So 3x plus 4 squared. I can take 3x, maybe I should color code these with a highlighter. I can take 3x and square it. I can take 4 and square that, and then in the middle, I'm going to take 3x and 4, multiply those and double it. Well, I'm going to get 9x squared plus 24x plus 16. And then in the second example you see here, 5x minus 2y squared, I have a binomial squared. I'm going to take 5x and square it, that's 25x squared. I'll take 2y and square it, that's 4y squared. And in the middle, I'll take 5x and negative 2y and double it. And when I do that, I get 10xy doubled, that's negative 20xy. There's my answer. Okay? Pause the video. Let's have you try with those shortcuts to find the product of these binomials squared. Let's start with that. Okay, I'm back. And in number 1, I'll take x and square it, I'll take 3 and square it, and I'll take 3 times x and double it in the middle. There's my answer, x squared plus 6x plus 9. In number 2, I'll take 2x and square it, that's 4x squared. I'll take 1 and square it, that's 1. In the middle, 2x times 1 doubled, 4x. For number 3, I'll take 4x and square it, that's 16x squared. I'll take y and square it, that's y squared. Now for the middle, 4x times y and doubled, negative 8xy. I got a negative there because I had a subtraction. And then the last one, take 3m and square it, that's 9m squared. Take n and square it, that's n squared. 3m times n doubled is 6mn in the middle. And that way you don't have to double distribute. So that's the first pattern. The square of a binomial. That's the first special case that you've learned. There's one more. It's called the sum and difference pattern. To find the product of x plus 2 times x minus 2, you can multiply the two binomials, and I'm just going to write here, double distribute. So let's double distribute. X times x is x squared. X times negative 2 is negative 2x. 2 times x is positive 2x, and 2 times negative 2 is negative 4. And you notice in the middle, when you do that, the middle terms cancel. Negative 2x plus 2x cancels out. You're left with x squared minus 4. This suggests the pattern for the product of the sum and difference of two numbers. When they say suggest, what they're saying is if you look carefully, because we had the sum and difference, we're adding and subtracting the exact same binomial, the middle terms will cancel out. Well, if that happens, it's easy. All I need to do, the sum and difference pattern, if I just take the first terms and multiply them together, let me color them in a color blue. If I multiply these together, I'd get a squared. And then if I multiply these together, I would get negative b squared, and there's your answer. It'd be a squared minus b squared. Okay? Let's try that on this problem. I would take x times x, which is x squared, and 3 times negative 3 is negative 9. That's it. That's all I have to do because I have the sum and difference of the same binomial. Okay? Let's try that here. T plus 5, t minus 5 being multiplied. Can you see the sum and difference of the same binomial? Well, it's easy. T times t is t squared, and 5 times negative 5 is negative 25, and there's my answer, t squared minus 25. Or, in this problem, can you see the sum and difference of the exact same binomial? It's easy then. Take 3x times 3x, that's 9x squared, and y times negative y is negative y squared. There's the answer. Now this shortcut only works if you have the sum and difference of the same binomial. Why don't you go ahead and try on these three? I'm going to pause the video, you try. Okay, I'm back, and here are the answers. So I have the sum and difference of the same binomial, so x times x is x squared, and 10 times negative 10 is negative 100. There's my answer. Or here, I got the sum and difference of the same binomial. 2x times 2x is 4x squared. 1 times negative 1 is negative 1. 4x squared minus 1. And here, I got the sum and difference of the same binomial. X times x is x squared. 3y times negative 3y is negative 9 squared. There's the answer. This is a really great shortcut instead of you having to double distribute. Now, if you don't know the two shortcuts, that does not mean that you won't get these right. It just means you're going to have to double distribute, and that takes more time. So if you're one of those people that are like, I'm feeling rushed on tests, well, then that's the next question. Are you doing it in the most efficient way, or are you doing it the long way? If you're doing it the long way, you're going to be more rushed. You always want to do it the most efficient way. So these two special cases, the sum and difference pattern and a binomial squared, which you saw in the previous slides, these are things that you want to know. This applies to mental math as well. Sometimes in class you see me and I'm not using a calculator and whipping out answers, and I can guarantee it's not that I'm super smart. I'm using these little techniques that I've learned to make the problem simpler. Like, look at this problem. I want to figure out 26 times 34 with mental math. Well, I'm either going to have to write it out on paper, or look at this little cool shortcut. 26 times 34 would be the same as if I take 30 minus 4. Now look at that. 30 minus 4, there's my 26. And then 30 plus 4, there's my 34. Now you might be like, why did you write it this way? Well, look carefully. Isn't that the sum and difference of the same binomial? Well, then there's a shortcut. 30 times 30, that's easy, it's 900. Negative 4 times positive 4 is negative 16. The answer to this is 900 minus 16, it's 884. Okay? That would work on problems like this too. Let's try, what about 18 times 22? Well, I don't know what 18 times 22 is, but I could quickly do this. 20 minus 2 is 18, and 20 plus 2 is 22. 20 times 20 is 400. Negative 2 times positive 2 is negative 4. The answer has to be 396. I'm not doing 18 times 22 in my head. I'm just making this into a simple addition and subtraction of binomials, and now it is easy to figure out. Okay? So this is a good thing to know for mental math when you get into certain problems. Again, that's how we can get some of these done without a calculator. To wrap things up, solving multi-step problems. The color of the dark patches of a border collie's coat is determined by a combination of two genes. You do these in biology. An offspring inherits one patch color gene from each parent. Each parent has two color genes, and the offspring has an equal chance of inheriting either one. The gene capital B is for black patches, and the gene small r is for red patches. Any gene combination with a capital B, which means black patches, results in black patches. So that means the black patches are the dominant gene. Suppose each parent has the same gene combination, capital B, small r. So they have the black patch gene and the red patch gene. The Punnett Square, which I know you use in biology, shows the possible gene combinations of the offspring and resulting patch colors. So if I look, if the first parent has both genes in the second, one combination, maybe I should use a different color here, one combination is going to be a definite black patched collie dog. Okay, we got both the black patch genes. This combination is going to cause the collie to have black patches because the black patch is the dominant gene. So is this combination, B and small r. But there's one combination here that's going to give the dog red patches. It's the double R. Okay, we don't have the dominant gene. So what percent of possible gene combinations will result in black patches? Can you see 3 out of 4? It's 3 out of 4 for this, and 3 out of 4 would be 75%. So there's a 75% chance that collie offspring is going to get black patches. Show how you could use a polynomial to model this. Well, take a look. Here, you can see we have one half of the parent's offspring is black, or one half gene black, one half gene red, and it's the same here. So look at what they're doing. We're taking 0.5b plus 0.5r times itself. Well, notice that? That's a binomial squared. That's the first of the shortcuts that I showed you on the video. Okay? So if I take 0.5b and square it, I'd get 0.25b squared. If I take 0.5r and square it, I'd get 0.25r squared. And if I take 0.5b times 0.5r and double it in the middle, I'll get 0.5br. Now, this is matching the diagram. Take a look at it. Let me get a highlighter. Okay? Can you see how 1/4 of the diagram is b squared? Is it b times b squared? This is saying 1/4 of the diagram should be b times b. Okay? This is saying 1/4 of the diagram should be r times r, which you can see there. And this is saying half the diagram should be a mix of the black and red gene, which you see there. So this binomial squared is completely matching that Punnett square. Okay, so I could use a polynomial squared to model the same picture. I'm going to pause the video here. If you have questions, make sure you ask in class.